Hi, Marina. Getting back to your question. Um, Here's your question. Biotech company tracks their daily profits and has found that the distribution of profits is approximately normal. So this is a normal distribution problem with a mean of $21,400 and a standard deviation of about $650. The question is, what is the probability that the profits will be less than 22,667.50 or greater than 22,947 dollars. Now let's do this together. Well, actually, I'll show you. I'll start by drawing the situation. That way you can see it more clearly. So we have a normal distribution. So I'll try to draw a normal. Not bad. We have a mean, which is $21,400. So the mean on a normal, standard normal distribution is in the center here. And we say that that is $21,400. They tell you that the standard deviation is $650. So I'll write it up here. Standard deviation is $650. The question is, what is the probability that the profits will be less than 22,670? So 22,670 is more than 21,400. So I'm going to draw it here, even though it may not be to scale, but I will say that this is 22,667.50, and it's less than 22,947.90. So 22,947.90 is let's pretend it's over here. I don't know what it is, but I'll just draw it since it's the relative positions. So this is 22,947 exactly. So really what I want to do is find the probability that it's greater than 22,667, so more than this, and less than this. I'm going to shade it in. So I'm going to shade in what I'm looking for. So the red area, where I'm coloring it in, is what I'm looking for. So I'm looking for the probability of that. Now, to do that, I need to use my standard normal table. The reason is because the average for this situation is 21,400, and I want to find the probability that it's write it out. I want the probability that x, whatever we're looking for, is between it's greater than 22,667, right, and less than let me write it out here, and less than 22,947. That's what I'm looking for. So I'm looking for the probability that x is greater than 22,667.50 and x is less than 22,947. We don't have a table for this. All of the normal tables, the normal probabilities, there's a normal probability situation for all sorts of things, but we don't have the area that for this situation. However, since it's all a normal probability table, we can use the standard normal table. The standard normal table has standardized all of the normal situations. So I'm going to draw this here as best I can. Exactly the same. And I've lined it up. On a standard normal table, the mean is 0. So let me draw that in. And I've lined it up so that you can see. So the mean is 0. So what I want to do using the standard normal table is I want to find the equivalent z-score for 22667.50 and also the equivalent z-score for 22947. That way, using the table, I can find out exactly what the probability is using our table, which is equivalent to the probability of our situation. So let's do that. So as you can see, I've shaded in my standard normal table, which is here. That's standard, and this is non-standard. And if I find the area of the blue region, which equates to the probability, I also find the area of the red region if I find the equivalent z-score that corresponds with 22667.50 and 22947. So there's a formula to find that. So I'm looking for really z1. I'll call it z2. All right. I don't know what they are. So my first job is to find what z1 is, and there's a formula, and the formula that you see in the notes and in the lessons is z1 equals x minus mu over sigma, or since we can pretend that it's a sample, it's the same as x minus s. Sorry, x minus x bar, or the mean, over s. Okay, so z1 will be x, which is in this case 22667.50, minus the mean or the average, which is 21,400, and I divide everything by the standard deviation of 650. Now I'm going to bring my calculator up, and I see that 22,667.5 minus 21,400 equals, and divided by 650 equals, this is 1.95. So I know now, let me erase this question mark. I know now that z1 is 1.95. Right? My next job is to find z2. z2 is 22,947 minus the mean, x minus mu, 21,400, divided by 650. And I'm going to bring my calculator in again. 22,947 minus 21,400, and that is equal to 1547. Divide that by 650, and we get 2.38. So now I'm going to erase my question mark here because I know what it is. And this is 2.38. I now know that the probability that x is between 22,667.50, that x is between that and 22,947, is exactly the same as the probability that that z is between 1.95 or greater than 1.95 and less than 2.38. The only thing we need left to do is find what that probability is. So we use our tables to find areas. So we can use our table to find the blue area. So the standard normal table that we use, one moment. So I brought up my formula. It's the same formula that you have in the back of your textbook and also in the formula and tables link. So this table, and they're different for different books, this table, but they do the same thing. This table shows us the area under a standard normal curve. If you look, the table at the top, this picture tells us how it works. So we have a standard normal curve, as you can see, and we have 0, and the area that's shaded is the green area, and it goes in this, and there's an example here, it goes up to 1.96, and that tells you that the area is 0.4750 or 47.50%. So to find this area, we look up 1.9 and then we go over to 6, and you see it's 4750, right? And that's how we use this table. So the reason there's only one side of this table is because it's symmetrical. Whatever is on one side is the same as the other side, but you have to be careful of the negatives since it starts at 0 for the mean. So we're looking for, so I'm going to move this out of the way. We're looking for greater than 1.95 and less than 2.38. Since we have this situation, what we need to do is find first 2.38. The reason is 2.38 will give you, let me write it out. 2.38 will give you 2.38 will give you the entire area, the blue, they're not the exact same blues, but the blues from 0 up to 2.38, because that's the nature of the table. So we're going to bring the table in, look for 2.38. 2.3 is there, and 8.08 is here. So 2.38 is right there. 2.38 is 49.13% or 0.4913. So I know this entire area is, let me go back to this. This entire area is, the entire blue area is 49.13, 0.4913. However, I don't want that first part of that blue area, that darker blue. I don't want that. I'm only looking for the lighter blue area, which corresponds to just the red area. So I need to, the table gives you the area from 0, so you have no choice. From 0 to 2.38, the area is 49.13, but I don't want the blue area, the first darker blue area. So what I have to do is I need to subtract that that larger blue area, the darker blue area. And that darker blue area goes from 0 to 1.95. So I'm going to bring my table up again, and from 0 to 1.95, so I'll go to 1.9, which is there, and 0.05 is there. So 1.95 is 47.44 right there. So I know that this area in here, the dark blue area, is 0.4944. No, sorry, that's a mistake. 4744. Let me fix that. 4744. And that's just the darker blue area. That's just this area here. So if I have this total blue area here as 4913 and I subtract 4744, I'll just erase it. Basically, when you subtract, you're erasing it. So as you can see, I've erased the first darker blue area, which is 4744, minus 0.4744. So what we're left with when you subtract that away is just the lighter blue area, which corresponds to the X scores of 22,667 and 22,947. It corresponds to the area between them. So let's bring our calculator up. 0.4913 minus 0.4744. and that gives us 0.0169, which in percentage 1.69%. So what that tells us is that there's a 1.69% chance, or 0.0169 probability of getting a salary between, getting a profit between 21,400 and also, no, sorry, 22,667.50 and 22,947. I hope that is clearer for you.